Hello, Prof. I'm recording this video for showing our project. For the first part, I want to show you our code and introduce it briefly. And we use, at the first line, we use a library named drive to control the L298 motor driver. And here is the library we use. For the line 3 to line 8, we define the pins controlling the L298 and create a drive instance. We set pins 26 and 27 to control the left wheel driver and pins 25 and 33 for the right wheel driver. For the line 10 to the line 12, we define the joystick pins with pin 14 controlling the vertical and the vertical axis and pin 12 controlling the horizontal axis. To the line 14 to line 18, we define the encoder pins, and for the line 20 to the line 31, we declare the global variables. This variables is for store parameters like encoder counts, the machine's speed, and orientation. For the line 33 to the line 43, here we initialize serial communications. We set encoder pins and inputs and configure interrupts to trigger on falling edges. Count-on inch encoder pause to calculate the robot's displacement and the speed. And for the line 45 to the line 64, we read the integer data from the joystick and map the x value from 0 to 1023 to a range of minus 100 to 100. This is for control forward speed, and determine the motor actions based on x and y values. And to the line 66 to line 89, this is the calculate process to calculate the speeds for the left and the right wheels, and we already show the calculation process in our project in our report. And let's say the line 91 to the line 101. This code is to calculate the speeds of the left and the right wheels. Then we compute the robot's displacement, orientation angle, the changing of angle, and the total movement. And this line is to update the robot's position coordinates to track the machine's location. For the line 103 to the line 117, this is for output the robot's relevant information for display. And then I want to introduce the simulation result. We can see we use the hardware. The hardware we use is the ESP32, the joystick, and the two encoders. Because the walkie does not have the option for the motor driver, so we use the 4 LEDs to simulate and display the driver's power status. Um, so the simulation will begin. I want to show the joysticks first, to show how we control this machine. When we move in the joystick, uh, for example, I would control it to move forward, and we can see the second and fourth LEDs is light up. This means the two motor drivers can control the. It means that the ESP32 can control the L298N motor driver, so we can move the robot. And because of the walkie wheel does not have the actual wheel rotation, so we manually adjusted the encoder rotation to simulate the robot's movement. So by rotating the encoder, we can observe the left wheel speed. Let me show that. Here is the left wheel. If I press this button, so the encoder is moved, and it means the left wheel is moved also. At the display, we can show the left wheel speed, the distance, the angle, and its location. And if I stop it, we can see the speed is become the 0, and the location, the angle, and the distance does not change anymore. And for the right wheel, it's also the same. So that is for the simulation process. Thank you, Professor.